Hi, hello. I am from Aislyn Technology. Today we can see how to implement smart irrigation system using Raspberry Pi. In this we are using soil moisture sensor. Using this sensor we can measure the soil moisture content, whether the water is present in the soil or not. In this sensor we can see there are 4 pins: A0, D0, ground and VCC. Through this sensor we can measure analog reading as well as digital reading. We need to immerse this electrode into soil, and we are using relay module. This is the relay we are using, which consists of 3 pins: VCC, ground and input. This is the control pin of the relay. Using these 3 outputs we can control the motor. This is the common, and this is the NO. NO means normally open and NC means normally closed. The input supply will come to NO and the output supply will go to water pump. And here we are using LCD display, which is I2C compatible LCD display, which is 16x2. Here we can see there are 4 pins, which is SDA, SCL, VCC and ground. SCL is used to communicate serially, which means SCL means serial clock pulse, and SDA is to transfer the data, and VCC and ground are used to power the LCD display. Using this we can adjust the brightness level. And this is the water pump, which is 12 volt water pump. Here we are using for irrigation purpose. And this is the 12 volt battery, each having 3.7 volt batteries. Totally it is 12 volt batteries. This is used to power up the water pump. And in this project we are using Raspberry Pi 3, which consists of total 40 pins, and which consists of 4 USB ports and 1 Ethernet port. And we can plug the earphone here. And this one is used to connect the camera. This one is HDMI port. We can interface with desktop. And this one is the USB port, which we are using for dumping the code and power up the Raspberry Pi. And here we can connect the display. And this is the SD card, which is connected to Raspberry Pi. Here we are installing the OS and all. Now we can see how to interface the all components with Raspberry Pi. D0 pin of the soil moisture sensor I am connecting to the GPIO21, and ground of the sensor I am connecting ground of the Raspberry Pi, which is 6th pin of the Raspberry Pi. And VCC I am connecting 3.3 volts of the Raspberry Pi. Now we will connect the LCD display to the Raspberry Pi. SCL of the LCD display I am connecting SCL of the Raspberry Pi, and SDA of the LCD I am connecting SDA of the Raspberry Pi. VCC of the LCD I am connecting 5 volts of the Raspberry Pi, and ground of the LCD I am connecting ground of the Raspberry Pi, which is pin number 14. Now I am connecting relay. Control pin of the relay I am connecting 18th pin of the Raspberry Pi, which is pin number 12. And VCC of the relay I am connecting 3.3 volts of the Raspberry Pi, which is pin number 17. And ground of the relay I am connecting ground of the Raspberry Pi, which is pin number 20. Now we will connect the water pump to the relay. Positive side of the water pump I am connecting common, and battery supply is connected to the NO pin of the relay. Ground of the water pump is connected to the ground of the battery power supply. Like this we can interface the soil moisture sensor LCD relay and water pump with Raspberry Pi. Now we can see how to dump the code in Raspberry Pi for smart irrigation system. First we need to open the Thony IDE in Raspberry Pi. After that we need to write the Python code for smart irrigation system. This is the Thony IDE. This is the code for smart irrigation system. Here import rpi.gpio as GPIO means here we are configuring the GPIO pins, and import drivers means this is the library of LCD display. In this all predefined functions are declared. Import time means using this we can give the delay in the program. We are setting GPIO pins as BCM mode, and we are calling the display driver.lcd. Here this function will initialize the LCD display, and sensor pin, which is the pin of the soil moisture sensor. Here we are collecting the data using GPIO 21, and here we are using pin number 18, which is connected to relay to control the water pump. Here we are setting the GPIO pin as input pin, which means we are collecting the data from the sensor, and this relay pin is set as output pin, which means we are controlling the relay. Here while true loop is used to continuous execution of this system. Here whenever the soil is wet means whenever the sensor pin is low, that time we are turning off the relay. Here relay logic is high for off condition, and we are printing on display like soil is wet and water pump is off. This soil is wet, it is printed on first row, and water pump is off, which is printed on second row. This is the row number. If the condition is not satisfied, then we are setting the relay as low, which means relay will turn on and water pump will on here. And we are printing as soil is dry in first row. In second row, we are printing pump is on. Here we are giving each 2-second delay so that we can display these strings on LCD display. Whenever we press any key like Control C, then program execution will stop here, and we are cleaning up the all GPIO pins, and we are clearing the display as well. To run this code, we need to click on Run button. Now we can see practically how this smart irrigation system it will work. Now we can see here the moisture sensor is dipped in water. That means the soil is wet, like that we are testing here. Now here we can see soil is wet and water pump is off. Whenever the soil moisture sensor is outside the water, then pump will on. And we keep the moisture sensor in water, the pump will off. We are printing here, pump is off. When we remove the soil moisture sensor, then pump is on. Now we can see pump is on. Thank you for watching our video. Please like, share and subscribe our channel.